So in this lab, we're going to look at the relationship between pressure and temperature. So instead of just using a syringe like the last two labs, I'm actually going to use this Erlenmeyer flask with a stopper and then this tube. That is actually going to connect to our gas pressure sensor. The reason why I'm doing this is just so that way I can place this Erlenmeyer flask into different solutions at different temperatures. So that way we can measure different temperatures. Now, because I am using a glass Erlenmeyer flask, the volume is not going to change. And once I connect this to the sensor, no air can go in or out of the Erlenmeyer flask. So that way our amount of gas is not changing. This way we can look just solely at the relationship between the temperature and the pressure. Now, pressure is going to be measured on this device on the left, like we've seen previously. To measure temperature, I'm going to measure temperature of the solution using this smaller thermometer. So what I'm going to do is I'm going to take this bowl of just room temperature water, and I'm going to stick my thermometer in there, and we can see what the initial temperature is. And I'm going to set my Erlenmeyer flask inside of it, and I'm going to push it down a little bit so as much of the water is covering the Erlenmeyer flask as possible. So at room temperature, which we're seeing that this solution is going to be 29.8 degrees Celsius, the pressure is going to be 98.94 kilopascals. Next up is a separate bowl of just a little bit of warm water. So I'm going to measure the temperature, and I'm going to stick my Erlenmeyer flask in there and hold it down. And I'm going to wait until the pressure stabilizes a little bit, as well as the temperature over here. It looks like the temperature is going to be around 42.0 degrees Celsius, and the pressure is going to be about 103 kilopascals. Now we have a slightly warmer solution. I'm going to add the Erlenmeyer flask into the container, and we can see the effect on pressure. And we can see that the temperature is increasing as well. So it looks like the temperature is stabilizing about 49.6 degrees Celsius, and the pressure is going to be about 105.33 kilopascals. Now we have an even hotter solution, which I'm going to wait for the temperature to stabilize and see the effect on pressure. Looks like the temperature is still increasing a little bit. Okay, so it looks like the temperature is actually about stopped at 59.2 degrees Celsius. And the pressure is 108.27 kilopascals. Now this is going to be a very, very hot solution. Where we can see it's in the mid-70s right now. So the temperature is going to be, still jumping around a little bit. So the temperature looks like it's about steady around 74.4 degrees Celsius. And it's jumping back up again. Okay, we're gonna wait for it to stabilize before we take our measurement. Okay, so it's sitting at 76.9 degrees Celsius, and the pressure is about 111.78 kilopascals. So for this final temperature measurement, we're actually going to go with a cold solution. Now I put some ice cubes into this container to hopefully cool it down a little bit. It's not going to get all the way down to the freezing point of water, which is 0 degrees Celsius, but it's going to be a lot lower than what we have seen for previous measurements, where it's already jumped down to less than 8 degrees Celsius. Now the Erlenmeyer flask is in the ice water solution, and we're seeing it's about 5.7 degrees Celsius. And we are seeing that the pressure is still dropping, but it's about 92.3 kilopascals. And it's dropping even more. So the temperature is going to be about 6.4 degrees Celsius, and the pressure is about 91.76 kilopascals.